So today we programmed ASIC 1 controllers. Those are pre-programmed controllers. Most people think ASIC 1 controllers are easier to program, most but not all, because you don't really have to build a program so much as choose from the options that we provide. But there are a lot of cases where we don't have a pre-programmed controller that meets the sequence of operation needed by the piece of equipment that you're trying to control. And so that's where the programmable ASIC reline becomes useful. And these are the types of applications. It's all the central plant stuff is the most common cases. And so sometimes people say, well, when do I use an 8100 for a rooftop or an air handler as opposed to an ASIC 3? And these are some of the kind of dividing lines that I think of. If there's any sort of VFD required, then you have to use an ASIC 3 because we don't have any duct static pressure awareness in the 8100. And then discharge air temperature control is another one that is usually points you in the ASIC 3 direction, because there's everything we're doing in ASIC 1s is for zone or room temperature control. I mean, you could extend that to return air temperature control, but it's not really meant for discharge air temperature control. And then big lighting projects, also ASIC 3s have been used for. There is a lighting output in ASIC 1s, but it's like one zone. And usually with lighting projects, you want a lot of binary outputs. And so that's where ASIC 3s, possibly with USB I/O, if you need more digital output, you could use for lighting. But I don't think lighting is very common in terms of what our customers do. Usually a separate contract, separate project. And so documentation-wise, there's some documents we'll refer to while programming the controllers from the help menu. There's an installation guide that talks about how to ground the controllers and the relay ratings and pull-up resistors and stuff like that. And then there's not an application bulletin or an engineering guide because there's no pre-programmed sequences, but there is what we call the object definitions, and that gives you some background information about there's a bunch of pre-programmed objects that are available, and you drag on different objects for different functions, and then you connect them to build the sequence, and that's what we're going to work on this Wednesday. And just like the ASIC 1s, there's also some PDF files in the partner portal that you might want to find if you want to do some printing out. And actually, some of the help files are now linked to by PDF from the help menu, and that's for some of the newer products I mentioned. New products, we're just going to do PDF. The expert recent versions have had some PDF awareness where when you choose a PDF file from the help menu, it actually launches the default PDF viewer. So any Windows 10 computer, Edge can be the default PDF viewer. If you're a Windows 7 computer, which I don't think many people are using anymore because I think Microsoft officially pulled support for it. But if you had a Windows 7 computer, you would need to have some PDF reader because ASI Expert is not its own PDF reader. It's just going to launch the default PDF viewer or reader. And so this is where we would do the hardware tour, the 9540. And I'll show you a picture. Let's see what we have on our website. I don't think we have a picture of one without a cover on it, though, which is okay. So there are two main ASIC 3 controllers. There's the 9540, which is the one we happen to have on our training kits. And then there's a 9520. And in the ASIC 3 line, the last two numbers are the number of input and output points. So the 6115 is actually a relatively new controller. And so it is fully programmable. It's the same form factor as the pre-programmed VAV controller, but it gives you the ability to have a fully programmable VAV controller. And it actually has a few more inputs and one more analog output. It has the same number of digital outputs. So it has 5 TRIAC outputs, just like a 6100. It has 2 analog outputs, which is 1 more than you have on a 6100. And it has 8 inputs, which is 2 more. Actually, it's 3 more than you have on a 6100 because one of the 6 inputs on a 6100 is the airflow input. We don't count that. So it's got 1 more analog output and 3 more inputs. And it actually can accommodate up to 2 airflow sensors. This controller happens to have 1 airflow sensor, but we can install a second airflow sensor here if you had there's still people that need dual duct controllers. And then in some healthcare applications, we have what we call tracking controllers that control 2 VAV boxes, one for supply and one for exhaust. And we adjust the exhaust CFM set point based on the supply CFM. There's also this 9536, which we've recently taken out of production, and it has 36 I/O points, which is 12 relays, 8 analogs, and 16 inputs. The 9520 has 20 I/O points, 8 relays, 8 inputs, 4 analog outputs. And the 9540 has twice the I/O of the 9520, so it has 16 relays, 8 analog outputs, and 16 inputs. So if we look at this controller, here's all the I/O points and the power are all on this one side of the controller. And we did that intentionally. We thought it might make panel building easier to have all the main wiring coming in from one side. But because of the number of I/O points, there's actually double stacked terminal blocks. And so you can see the labeling here on the cover. So here's the first 4 relays, and then below that is second 4 relays, second set of 4. And then moving down, here's 9 through 12. Below that is 13 through 16. There's power up here too. The power supply on the 9540 is a little bit different in that it's an isolated power supply. So that's why there's this separate ground terminal. And what the isolated power supply allowed us to do was for some telco applications, they wanted to connect our controllers directly to a building UPS that happened to run on negative 48 volt DC. And so we designed a power supply to make that easy. So this controller almost always runs on 24 AC, but it can run on up to negative 48 volt DC. And then here's the analog outputs, 4 on top, 4 below, each with a common link to ground. And then here's the inputs, 1 through 4 on top, 5 through 8 below, and then moving down, 9 through 12 on top, 13 through 16 below. And then down here in this section, you see it's marked service port, Ethernet, and SD card. And that's what we call the brain board. It's actually a separate board that sits up above the main I/O board that has all the memory and the main processor and all that sort of stuff. And there's actually a squarish USB port here, like you see on a printer, so that lets you plug in directly to the controller. Maybe you don't know its IP address or you need to change it because you can't connect through the Ethernet port if you don't know its address. But there's an Ethernet port. Hardwired Ethernet can do both ASIC protocol and BACnet IP. There's an SD card slot here that we've added since the original release of the controller, but it was added there mainly to be an easy way to increase memory in the future. And so we're finally getting ready to use it many years after the initial release. And so what we're going to use that SD card slot for is to save all the programming in the controller so that if this controller were to fail, you could just install a new controller in place of it and just move the SD card from the original controller to the new controller. And then the new controller will just run exactly the same programming as the original controller without you needing to load any new programming into the controller, into the new controller. There's also a slot here for a battery, and ASIC 3 controllers, except for the 6115, have hardware clocks, but they need a battery to keep the clock running when the controller doesn't have power. And so there is actually mention of that battery in the documentation. So from ASI Expert, if I do help ASIC 3 INST_9540, which is the installation guide for 9540 controllers, There's a section here in communications, battery B1. So it backs up the real-time hardware clock. It should last for about 10 years. And we do recommend when you replace it, to replace it specifically with this Panasonic part number. Panasonic batteries apparently do better with reverse polarity, because it says here, if reverse current is applied, you could get some kind of, it talks about a fire hazard and sparks and flames and stuff like that. So just be careful that you observe polarity when you put the battery in, and when you replace it with a Panasonic battery. Let's see. What? Actually, this you can't really see in the picture with the cover. There is a slot you could directly connect a Wi-Fi card that we sell into here, but we've recently released what we call the Intelify module. It lets you make the USB connection to join a Wi-Fi network, and that makes it easier if you've got your controller installed in a metal enclosure. So we include a USB cable so that you can install the Intelify module outside the metal enclosure, whereas when you plug the card directly in, you would need to get your own coax cable to mount the antenna directly outside of the metal enclosure. Or you could use a fiberglass enclosure, but most people use metal enclosures. So that Intelify module, I think is here on our webpage. Let's scroll down. There it is. So this is the Intelify module. So it's got a USB cable on it. It's ruggedized, it's sealed, so it can be exposed to the elements. And it's got an omnidirectional antenna. And so that way we can do either ASI protocol or BACnet IP over Wi-Fi. And that's any controller with a USB port, which is all of the ASIC 3 controllers, but not ASIC 1 controllers. Then there's what we call a USB host port in here, which is like the flattish USB port like you see on your computer. And the main function there is you could do Intelify. We have USB I/O modules that can be connected. And if you have multiple USB devices, then you can get a powered USB hub. So here's the USB I/O expansion module. And so that has USB, like we call the device port here, and then the flattish part goes into the controller. So an ASIC 3 controller, its USB port has enough built-in power to power one USB device, whether it's USB I/O or Intelify. If you're using multiples, then you need to get a powered USB hub so to provide enough current to power all of the devices. So currently, I think you can add up to 2 USB I/O devices. I think that might be expanded to 3 shortly, but 2 is the published limit right now. Then there's 3 RS-485 ports here, and I can probably go to the real picture to give you a better feel for that. Now, stuff that you can see. So this is what we call the system bus, and it can also be BACnet MSTP. This one we call the local bus, and it can actually do ASI protocol, a Modbus where the controller acts as a Modbus master, or BACnet MSTP, whereas the system bus is ASI protocol or BACnet MSTP. And local 2 can also be ASI protocol, Modbus acting as a Modbus master, or BACnet MSTP. And our controller can also act as a BACnet router. So if BACnet IP is enabled, it'll take BACnet IP in through the Ethernet port, and then it can route through any or all of the 485 ports. So each of those can be set independently for protocol. There's a service button. One of the other functions for the USB host port is to do firmware upgrades. So if you load a USB drive with the right file and the right file name and the right location, you can quickly update firmware by pressing the the service button while inserting the USB drive into the host port. Then this light starts flashing after a few seconds. Then you can reset the controller, and then it's running new firmware. So you can, with the USB drive, you can update firmware in probably 15 seconds or less. most people end up, I think, using ASI Expert to do firmware upgrades. It takes longer, but it's maybe a little more intuitive. It seems a little less intimidating in terms of, am I doing everything in the right order? And then we have some DC power options here as well. We can give you 5 volt and 12 volts DC at up to 100 milliamps. You have some field devices that need those voltages. And then actually, I didn't mention the relays. There are red LED indicators for each of the lights that tell you which of the relays are on. And the 9520 is very similar. The main difference is it has less I/O points, but there are some other differences as well. So beyond the I/O differences, it only has, I shouldn't say it only, it has one less RS-485 port. So there's a system bus, which can be BACnet, MSTP, or ASI. And it has a local bus, which can be ASI protocol, can act as a Modbus master, or it can be MSTP. And it doesn't have the 5 volt and 12 volt DC power supplies as well. And the power supply itself is less sophisticated. It runs just on 24 AC or DC. It doesn't do that negative 48 DC. It doesn't have that option. So I think that's most of the items on the control. Oh, there's these pull-up resistors. You don't see it with the cover on because they're below the relays. But there's a different resistor for each input that you might change or remove depending on the type of signal you're connecting to that input. And we'll talk about that as we're programming the controllers on Wednesday. And also there's a little jumper on that you can set if you connect a 0 to 10 volt DC signal into the controller. And you can actually see it better here. There's a jumper, and it looks the same on the 9540, except there's 16 because there's 1 for each input. So you set the jumper to connect the 2 pins if you're connecting a 0 to 10 signal in. Otherwise, you don't have the jumper connected. Right now, these jumpers are all not connecting. There's a second pin that's this kind of gold strip here. And so that allows you to connect 0 to 10 volt DC input to the controller. This gives you a little better picture about that clock battery. It's in a little, a little tucked away, but you can carefully kind of punch it out if needed. It's best to replace the clock with power applied. Otherwise, if you take the battery out while power's not applied, it'll lose track of time. So when you power back up, then you'll need to resynchronize the clock. I think that's most of the hardware tour.